So now we are going to study the Michaelis-Menten equation. From this graph, what do we get? Okay, now for this equation, it was given by these scientists Lenore Michaelis and Maud Menten in the year 1913. So they have given this equation, which is popularly known as Michaelis-Menten equation. So let us consider the following equation. Now girls, at first you know that there will be an enzyme and a substrate, right? So this enzyme and substrate, they will bind together. So when they bind together, they will give rise to the formation of ES complex, right? So the rate of formation of ES complex is given by the constant K1 here. K1 is the rate of formation of ES. Now, actually, this ES complex, when it form, it may revert back to E plus S. Sometimes that substrate, instead of forming a product, sometimes it may be released back from the enzyme without forming a product. So this backward reaction, that is the dissociation of the substrate from the enzyme, or the breakdown of ES, is given by K minus 1. Okay, when the ES it breaks down to give rise to E and S, then it is given by the rate constant K minus 1. Or this enzyme substrate complex which has formed, the reaction will occur and the substrate will be converted into product and giving rise to the product and the free enzyme. Okay, the product will be free from the enzyme. So this reaction is given by the rate constant K2. Alright, so I hope this is clear. This is the equation 1. Now coming to the equation 2, here just take a look at this reaction. These 2, 3 and 4, how do we write? The rate of formation of ES, that is K1, alright, is equal to K1, the rate constant K1, into enzyme concentration and substrate concentration. That is the rate of formation of ES I had shown to you just now. Whereas the rate of breakdown of ES, that is that backward reaction, it is given by K minus 1 into substrate concentration. While the rate of formation of product is given by K2 into enzyme substrate concentration. So we get equation 2, 3 and 4. Okay, so therefore, considering the total rate of breakdown, okay, the rate of breakdown, that means when this reaction, when this ES here, alright, when this enzyme substrate complex, it will either break down to give rise to E plus S, or it will break down to give rise to product plus enzyme. Okay, it can break down either way. So the rate of breakdown, it will be equal to this one and this one. Okay, it will be equal to K minus 1 into E plus S, or it will be, let me show you in this reaction, the total rate of breakdown, it will be K minus 1 into ES concentration plus K2 into ES concentration, right? K minus 1 and K2. That is the rate of breakdown of ES complex. So from there we get the equation number 5. Now since ES and ES is common, okay, then we will get from equation 5, we will get K minus 1 plus K2 into ES. Since this ES is common, so we take it as common. Then in bracket we will get K minus 1 in plus K2. Alright, so this is equation number 6. So I hope till equation number 6 is clear. Please first try to understand this, then we will go further. Now, at equilibrium, I had already explained, alright, just now only, that at equilibrium what happened? The rate of formation of ES that is the enzyme substrate complex, is equal to the rate of breakdown of ES. Alright, so from equation 2, what do you get here? From equation 2, what do you see here? The rate of formation of ES is given by this equation, right? K1 into E into S, enzyme into substrate, and the rate of breakdown just now we had calculated is this one, the equation 6. So at equilibrium, what happened? The equation 2 will be equal to equation 6, that is the rate of formation of ES is equal to the rate of breakdown of ES. So we are getting this equation 7. Or here we see that this one, if you in how do you get this equation 8? You see here from equation 7, just do some maths calculation. Take this K1 this side, so since it is a multiplication, it will come this side as a division. Okay, it will come down, and carry the ES this side. Same here, since ES is here in this side it is multiplication, so this side it will come down as division. So that is the rule of mathematics, right? So if you take ES this side, it will come down, and K1 you take this side, it will come down this side. So we get equation 8. Now instead of writing K minus 1 plus K2 divided by K1, okay, this whole thing we will just write it as Km. Since K minus 1, K2 and K1, they are all constants, they can be combined into a new constant, that is Km. And this constant is known as Michaelis-Menten equation. So from equation 8 we will write E into S divided by ES is equal to Km. Alright, so we get this equation. Or if you take the EM this side and the ES this side, we will get this equation. Enzyme substrate concentration is equal to E plus S divided by Km. So now we get the equation 9. Okay, so I hope till here equation 9 is clear. Now if the concentration of the total enzyme, alright, remember girls, in a beaker I told you that suppose we have 100 molecules of enzyme, so that total concentration of the enzyme, suppose it is given by ET. Okay, suppose it is given, the total concentration of enzyme is given by ET, and that of the enzyme which is free, because you know from those 100 molecules some has already bind with the substrate, some enzymes are free. So altogether we know that the total enzyme is 100, so it is given by ET, whereas those enzymes which are free, which do not bind with the substrate, it is represented by E. Then then you know that the enzyme which have been combined with the substrate will be ES is equal to total enzyme minus enzyme which is free. Suppose girls, to understand this, suppose I have 100 molecules of enzymes, right? And suppose 40 enzymes are still free. Okay, 40 molecules of enzymes are still free, and 60 of them has already bind to the substrate. So those which has bind to the substrate is given by ES, right? They have bind with the enzyme, the substrate, so they will give rise to ES complex. Now that will be equal to 100 minus enzymes which are still free is 40. So 100 minus 40, that means 60 enzymes are already bind with the substrate here. So I hope this is clear. ES is equal to E total, that means enzyme total, minus enzyme which is still free. So from equation 10 we can, if we take the ES this side, Okay, to the left side you can see in equation 11, you take the ES to the left and the E concentration to the right. Okay, this one, you take the E this side and the ES you take it this side. So we get equation 11 because we want to find the concentration of the enzyme. Now substituting this value of enzyme in equation 9. Okay, just now we have see this we have get this equation 9. All right, this one, this equation 9 here, you substitute this value of E from here in this equation. Okay, in this one, so you get like this. Instead of E you get this one, ET minus ES into S divided by Km. Now from equation 12, again you have to do some mathematical calculation. You multiply because these are inside the bracket. Always inside the bracket, it means multiply. So you multiply S into ET, S into ES. So you get ET into S and ES into S, right? You open the bracket and you multiply by S. Now you get this equation. Okay, so all here till equation 14 you have to do mathematical calculation. In next line, what do you see? Now you can take this Km this side, so it will become ES into Km. So here I get only this one because I have already taken this Km this side. Next line, what you can do, you carry this ES this side. So since it is minus, if it cross this side it will become plus. That is the rule of mathematics if some of you didn't know that. Okay, so I'm just doing mathematical calculation. So you finally get this equation. Now next, what do you see here, that the ES is common right here and here the ES is common, so you are taking ES common outside. So inside the bracket Km and S will remain inside the bracket. Alright, so next line you get ES is common and inside the bracket you get Km plus S, and the right side it remains as it is, ET into S. So next line, what do you get? Now here again you carry this whole thing, this Km plus S that side. Okay, you carry it this side. Now since it is inside a bracket, again I told you that inside a bracket meaning multiply, so when you carry it this side it become as division. So you get this side, you get ET into S, ET into S divided by Km plus S, because you have already carried the Km plus S this side. And finally you get this equation 14 as, you can write it in this way, ET into S divided by Km plus S. So this is equation 14. Okay, so now girls, let us again take a look at equation 4. Here if you take a look at equation 4, the rate of formation of product is K2 into ES. But if you remember, I had explained to you, I had given you in the graph that at first, okay, this rate of reaction is given by V0. Okay, that is the rate of formation of product when the enzymes are, when all the enzymes they are not involved in the ES complex formation, because you have given only few substrate concentration. So some enzymes are free and some enzymes are bind with the substrate and they catalyze the reaction. So some only few products will form. So that is given by the initial velocity V0. So that is why from equation 4 here, okay, the rate of formation of product, we can write it as the initial velocity. Alright, here you can see from equation 4, we can write it as initial velocity is equal to K2 into ES. That is the rate of formation of product, K2 into ES. Now, substituting the value of ES from the equation 14 to this equation 15. So, just now we had seen that the equation 14, the ES is given by this equation, right? So substituting the value of this ES, okay, this value of ES, we will substitute it in the equation 15. Now what do we get? So instead of writing K2 into ES, now this value of ES from equation 14, we get ET into S divided by Km plus substrate concentration. Okay, so the rate of a reaction, it reaches its maximum when all the enzyme molecules are occupied. When all the enzyme molecules are occupied by the substrate forming the ES complex. So when all the enzymes, they are occupied by substrate, that means all the 100 molecules of enzyme, they already bind with the substrate. So at this stage, the total enzyme is equal to ES, right? Because all the enzyme substrates, all the enzymes, the total number of enzymes, which is 100, is already binding with the substrate. So ES is equal to ET. Now, the equation 4, it can be changed. Instead of writing the initial velocity, we can write as maximum velocity. Now, the initial velocity, that means when only few ES complex has formed. But Vmax is when the ES is equal to ET, that is all the enzyme they has already bind with the substrate. So we, instead of writing initial velocity, we can write Vmax, and instead of writing ES, now I can write ET. That means all the enzyme, all the total number of enzymes has bind with the substrate. So here in this case, when the velocity, it has reached its maximum, that is Vmax, now you substitute the Vmax for K2 into ET in equation 16. Now you see here, girls, this equation 16, we have K2 into ET. So instead of writing K2 into ET from equation 17, we can write as Vmax. So substitute this value in this equation, we get V naught is equal to Vmax S divided by Km plus S. So this reaction, girls, or this equation, girls, is very, very important, and this equation is known as Michaelis-Menten equation, and Km is referred to as the Michaelis constant. Okay, so this equation, it shows a relationship between the initial velocity and the maximum velocity as well as the substrate concentration. And from this equation, actually, we can derive other certain other relationships. So this is Michaelis-Menten equation, and it's very, very important for you to know, and you have to learn to by heart these different steps of derivation, how you will derive this equation.